So the part 2 is about concepts. Because, well, it may seem boring, but in order to do a proper product modeling, we need to actually delve into the concepts that are required, so that you would understand what you really model. So this is the case about every new area, that you need to understand the concepts, the terms that are used in that area before you can actually do things by yourselves. So please bear with me a little bit, and then in the afternoon we're going to do more practical things. So there are 3 central concepts to what we're going to do in the afternoon and pretty much throughout the whole week. So they are agent, system, and model. So 3 central concepts. So let's start with the concept of agent. So now when you think about this word agent, so what comes to your mind? So what are the associations, or how would you characterize an agent in your view?
Agents meet in Matrix.
Agents meet?
In Matrix.
In Matrix.
The movie.
Okay. Agents in the
Agents meet. It was.
Agents meet. Yes. Okay.
It's protecting the Matrix.
Okay. So this is a good association. So any other ideas that come to your mind? Whatever, I mean. That doesn't have to be related to software engineering or information technology at all.
Someone that stands to represent you somewhere.
Yes, someone that represents you, like your travel agent or your real estate agent. So any other ideas? So who is an agent?
The agent is offering something to me.
Offering something to me?
Maybe.
Like, you mean like a service provider?
Yes.
Yes, yeah.
It can be like physical or software oriented thing who can, how can I say, perform the operations.
Yes, act.
Act.
Yes, yes. So now you are coming to the meaning of software agent, really, or maybe.
It can be software agent, or it can be environmental agent, like a person.
Yes, yeah.
Like it shouldn't be just like physical, like human being. It can be also software.
Yes. So the main characteristic is, in your view, that it can perform actions, can do something.
Yeah.
Yep. Yes. So any other ideas? So this is not about being right or wrong, but just about ideas. Yep.
A person that is between our business and the market.
Yes, so mediator. Yes, another good meaning. Yes, thank you. So more ideas? Okay, so let's go to the definitions. The very general definition is that an agent is an active entity as opposed to a passive entity. So what do I mean by an active entity? Well, for example, obviously we here are all active entities. So then this means that we can be categorized as agents. Am I right? So we are active rather than passive entities. But this stand here is passive. Yeah, I mean, it is just an object. It's not an agent. It's an object. But it can be turned to an agent. Well, if someone would add here some sensors, so that would sense my height, for example, how tall I am. And then there would be some reasoning embedded here. And then this stand would have some actuators that enable this stand to change its height so that it would match my height, then I would call this stand an agent. So the automated stand that can be categorized as an agent, because it has three components. It has sensors. It is able, through sensors, it is able to sense its environment. It has actuators, and through actuators, it is able to affect its environment or perform actions. And in the middle, it has reasoning. So it is able to reason about the information that this stand agent receives from sensors, and then it is able to feed the results of that reasoning into actuators, so that the stand would react accordingly and would change its height in the given case. So the limits between agents and objects are not so straightforward always, or it's a better way to put it, so we can quite easily turn some object to an agent. Okay, let's go to more specific definitions. An agent is an entity that can act in the environment, like this imagined automated stand can act in the environment, and that acting, of course, is quite limited. It is just changing its height, but it is still acting in the environment because it affects the environment in some ways. Then an agent can perceive events, like in the case of that automated stand. That automated stand would be able to perceive my height as a series of events from the environment. And an agent is also able to reason, because with just perceiving my height and the ability to change its own height and nothing in between, so that there would be no point, because then somehow this stand would need to decide, that okay, my height is 170 centimeters, and so I need to actually raise myself to the height of 150 centimeters or so that it would be comfortable for me, to lecture using this stand here. Then the definition that someone proposed here already, this is the meaning of travel agent or real estate agent, an entity that acts on behalf of someone or somebody. And this acting on behalf can be acting on behalf of another person, or can be acting on behalf of some organization or institution. So these are relatively easy, I would even say trivial definitions. Are there any questions or anything you would like to add here? Of course, the meaning of an agent as a mediator is not present here, and the meaning of an agent as a service provider is not present here, but I assure you they are equally relevant meanings of agents, because for us these agents here serve in the first place as useful abstractions for developing software intensive intelligent social products. So this means that yes, an agent can be defined as a service provider or can be defined as a mediator. So now this is the official definition that you can find in many textbooks that are devoted to artificial intelligence, for example. So an agent is an entity that perceives and affects its environment and performs reasoning. So pretty much the same that I already expressed by those trivial definitions. And an agent is reactive, is able to react to the changes situations occurring in its environment. An agent is also proactive, meaning that it can initiate some actions by itself based on its own reasoning. Because reactiveness means that if there is some change in the environment, or some event occurs, or for example, if I push this stand, then this is some sort of action in the environment that this stand turned to an agent can perceive and react accordingly. So maybe this intelligent stand would be built in such a way that if I push it, then it would raise to the height that is the most appropriate for my lecturing here. So this is an event that an agent perceives and then reacts to that event. But an agent can also just reason based on its knowledge base, because an agent accumulates some knowledge over time. Like we humans, we accumulate knowledge over time. We think, reason, and then we initiate actions based on our reasoning. And this is called proactiveness, that you do something based on the state of your mind. And that is not immediately caused by some events in the environment. Of course, if we start analyzing it then in a more indirect way, everything we do is caused by some events that have occurred in our lives, in our environment, and have influenced us, but we do not need to become that philosophical here. So proactiveness means acting based on someone's state of mind, and that someone can be a person, can be an animal like a dog, for example. The dog also is proactive, not just reactive, or can be a software agent, can be a hardware agent, or a robot. Then an important feature of agents is that an agent interacts in an asynchronous way, meaning that if I interact in an asynchronous way, then I receive a message from another agent, from another human. Let's put it this way: someone sends me a message, and now I do not need to react to that message right away, but I may store that message in some buffer, and then I process the messages from that buffer in the order that satisfies my priorities and my needs. Whereas in synchronous communication, you get a message, and then the communication channel between you and another agent is established, and then you need to respond right away. So this is synchronous communication. But in an asynchronous communication, an agent has a buffer where it stores messages and then processes the messages from the buffer in the order that the agent deems appropriate. And this is what we humans do. This is what most software agents do, and also many robots interact with our other robots in the same manner. I think it's pretty intuitive, asynchronous communication. Now, an agent has some sort of internal structure that we call the abstract agent architecture. And in that internal structure, I already referred to knowledge base, that an agent has some sort of knowledge base where it gathers information, and that information in its knowledge base then is actually the source of a proactive behavior by an agent. So one of the components of the abstract agent architecture is an agent's knowledge base. Then I've already mentioned sensing the environment. For sensing the environment, we need sensors as components of an agent. And I also mentioned affecting the environment, performing actions towards the environment. And this is done through actuators. So each agent has some actuators by means of which it can affect the environment. And this affecting the environment through actuators can be as simple as sending messages to other agents, because this is also doing something towards the environment. I'm sending messages, so I'm affecting the environment, because someone is supposed to receive my messages, and then these messages can change that other person's or other agent's state of mind, for example. Or that message can, for example, change something physical in the environment, can, for example, start some machine, some equipment. And then in the middle is the controller that keeps it all together. And now you can see there are different arrows here. And these arrows mean here, this arrow means that an agent can act proactively based on the information stored in its knowledge base. So this is the arrow standing for proactive behavior. So there's some information, some state of knowledge, and this is fed into the controller, and then based on that information, the controller orders the actuators to do something. This is proactive behavior. Then there is reactive behavior, and the arrows for reactive behavior are the following ones. So this one, well, an agent senses something through its sensors, and that information is fed into the controller, and then controller orders the actuators to do something, either to send a message to another agent or to do something physically, like starting some equipment. Then there can be also more sophisticated reactive behavior. When an agent senses something, then a part of what an agent senses, or maybe all of it, is stored in its knowledge base. Then an agent may also check some condition in its knowledge base, and based on that condition then decides what to do. So meaning that this arrow is not used anymore, but instead this information goes from sensors to the knowledge base, and from the knowledge base to the controller, and from the controller again to actuators. So this, in other words, this means that that an agent senses something, checks some conditions in its knowledge base, and then based on the value returned by these conditions, performs some action, or maybe doesn't do anything if the conditions are then the respective ones that do not allow the agent to perform any actions. So does it seem as complicated or simple?
In this model, the sensor itself is a kind of a complicated structure. It's not just a photo element or a temperature element, because it should have an interface to knowledge base in order to save it.
Yes, yep. Yes, I mean, there can be different kinds of sensors. Of course, the simplest sensor is of the kind that just receives messages from other agents. But of course, there can be, like you mentioned, photo elements, and there can be like different different temperature sensors, humidity sensors, also location sensing. I think belongs here also, because it's also, well, it's there is a different system behind it. I mean, like all the satellites and so on, but it still can be viewed as a sensor for an agent, so that an agent is able to perceive its current location. So any other questions? So the most important things here are then reactive behavior, that goes then either directly from sensors to controller, from controller to the actuator, or via knowledge base from sensors to controller, from controller to actuator, and proactive behavior that goes from straight from knowledge base to the controller, from controller to the actuators.
But not necessary?
It is not. Yeah, it is not necessary for purely reactive behavior. But if it's upon perceiving something in the environment, we also need to check something in the agent's knowledge base. Then the knowledge base is relevant. Because, I mean, it's like the rules of this kind that express this kind of reactive behavior. They are called event condition action rules, meaning that I perceive some event, I check some condition, and then if the condition is true, I perform some action. So, but this is now, it's getting quite technical already. Yes. Then each agent has an execution loop. And the execution loop is actually quite intuitive. It means, it says that while the agent is unfulfilled, whatever it means. So, well, in the case of this digital pet Tamagotchi that lives inside this box, this being unfulfilled means that while this digital pet is alive, because as you know, I mean, it can also die if it's not properly cared for. Then this digital pet inside this box can die. So the meaning is that while this Tamagotchi, this digital pet living inside the box is alive. By the way, so one of the misperceptions about this Tamagotchis or digital pets of this kind is that the box here is Tamagotchi, the box you can see here. Actually, it is not. The box is just a local environment for the digital pet Tamagotchi that lives inside here, inside this box. This is just the home for the Tamagotchi. So while the agent is unfulfilled, or while the Tamagotchi is alive, in this example, sense the environment. Then based on the information that you perceive from the environment, update the knowledge base. And this can be also optional. It doesn't, I mean, you do not need to do actually this update in the knowledge base. Also reasoning is optional because you may react based on what you perceive from the environment right away. So optionally update the knowledge base, optionally reason, then choose actions and act. So as simple as that. Just sense the environment, update the knowledge base, reason, choose actions, and act. Of course, there are more complicated execution loops and for more complicated agent architectures, but we are not going into this in this course because here we view agents as modeling abstractions in the first place rather than sophisticated software agents. Okay, and this is that question, what is an intelligent agent? And I think we already covered it, or maybe some of you has some ideas you would like to offer for the meaning of an intelligent agent. Can your pet, I mean not digital pet, but a real pet at home, can the pet be viewed as an intelligent agent? Yep. Yes, well, about pets or about dogs, it's actually interesting. When we talk about automation, about automating some activities that humans used to perform manually but would like to get rid of them, then one of such activities is guarding the home. So, well, I have a private home, I need to guard it. And let's assume I live in a very kind of criminogenious area. So, and this means that I need to guard my home also at night. And this, well, what it means is that I need to wake up now and then and walk around the house to make sure everything is all right. But then at some stage I actually get tired of it. So because I would like to sleep at night rather than guarding my own house. So what do? Well, of course, I mean, I'm thinking about automation. I need to automate this activity of guarding my home. And the first idea that occurs to me for automation is getting a dog. Not just as a pet, but as a guard dog. I mean, a big one, this like a terrier or something. Yes. So, okay, I got a dog. I trained the dog, or someone trained the dog, and then well, I can leave the dog outside, and the dog would sleep there. And if there is something suspicious, the dog would bark, and these intruders would run away. And or they do not dare to enter my garden, my yard, because of that awful-looking dog. But of course, with dogs, it's easier to, for some criminals at least. I mean, they know how to cope with dogs. And somehow, I mean, they can eliminate the dog through them poison or through some other means. So I need some more sophisticated solutions for guarding my house. And then this is where technology comes to help me. So I can actually build or have built a bunch of software agents or some intelligent system consisting of software agents that guards my house. And this would be a much better solution. I can rely on this solution much more than on myself or on my dog. So there are this means that there are different stages of automation. So the first stage is no automation at all. The second stage is where I delegate the activities of guarding to my dog. And in this sense, my dog is also an agent. And now the third sense is, or the third stage is where I delegate my activities of guarding to a bunch of software agents who then take care of these activities. Okay, so what is intelligent agent? So the official definition is that an intelligent agent is an agent that is reactive, proactive, and social. So in other words, if I have just this stand as an agent that is reactive, reacts to my presence here, and is able to sense my height and change its own height according to my height, then this agent is not an intelligent agent because it is just reactive. But if we talk about this Tamagotchi, for example, here, living inside this box, then this Tamagotchi becomes hungry now and then. It develops social needs now and then. It would like to interact with its owner, would like to interact with other Tamagotchis. So then, in this sense, it is proactive, and at least this requirement for proactiveness is fulfilled here. But it is also social, because it interacts with other similar digital pets. It interacts with its owner. So I think that Tamagotchi satisfies the definition of an intelligent agent, because it is reactive, it is proactive, and it is social. And again, I emphasize here that it really doesn't matter here that proactiveness in the case of this Tamagotchi is actually results from many lines of code written in some unknown programming language in the case of this Tamagotchi. Because what matters is how the owner of that digital pet perceives it. And from the perspective of owner, I mean, certainly the owner, I mean, perceives the Tamagotchi as being proactive, because the Tamagotchi asks for food, asks for company, asks to be introduced to other similar digital pets. So for sure it is proactive. It doesn't mean how it is implemented. What matters is, I mean, how it actually behaves, how it interacts with its owner. Any comments here? Or?
Social in this case means interacting with the similar devices or with a human?
Both.
Both?
Yeah, both.
example, the guarding system that guards your house, probably it should be closed from the other systems in order not to be hijacked or
yes, yes.
But it should be, of course, social
Yes,
toward
yes.
the human, because
Yes,
you need
yes,
to the
yes,
owner.
yes,
So
yeah.
it cannot be intelligent then.
Yes. Well, I mean, of course, you can limit this, the social behavior. The main thing is that its ability to, I mean, the main thing is the ability of each individual agent that actually forms a part of that system to interact with other agents. But of course, we can limit our systems. I mean, not all systems have to be. All systems do not have to be open. So we can limit this, but still, I mean, I think this home guarding system also has these features of reactiveness, definitely reacting to the events going on in your garden, proactive, trying to predict some events, maybe warning the owner that you better actually protect better given area in your garden, because it's easy to intrude. Maybe that system, the agent there forming a part of the system has noticed some suspicious activity in a given place, and then can give advice based on the reasoning that it has made based, and the reasoning is rooted in the information that the agent has gathered with the help of sensors. And of course social. But social can be limited. It is still an open system because you can still add agents to your guarding system. Different, agents taking care of different sub areas of your system. But this doesn't mean that it has to be open to all other systems around. So any other examples of intelligent agents? Smartphone, yes, definitely conceptually can be viewed as an intelligent agent, yes. Any others? Okay. So in many cases, we express knowledge about these agents in terms of anthropomorphic qualities. And these are qualities that relate to humans in the first place. We talk about beliefs of agents. We talk about responsibilities of agents. We talk about their expectations. I mean, even if they are software agents or robots or a smartphone, for example, we can still use these categories. We talk about their capabilities. We talk about their goals. An agent has some goal that it is trying to achieve. We talk about their desires. Desire is actually kind of pre-stage of goal. They desire something I would like to achieve, but I don't know how, and then the goal is more specific. We talk about intentions. So intentions are goals that have been chosen by the agent for implementing, for achieving. So we use different anthropomorphic qualities, and we use them because it's easy for us to express ourselves using these qualities, because we are used to this. This is what we also apply to humans, and that's why it is very comfortable to also apply these qualities for software entities, because this makes our design process a lot easier. So there are three kinds of agents, and I think I already mentioned there are biological agents like a dog or a human, and then there are man-made agents like, for example, a Tamagotchi I've already told about a software agent, an industrial robot, or some other kind of robot, like for example the Mars exploration rover. This can be viewed as an agent because it should cope in a hostile environment on the planet of Mars. It should be able to perceive that environment. It should be able to affect that environment, for example, moving around there or taking probes from the soil of Mars. It should cope with all these activities, and of course it should be able to reason because this is the central part. It should be able to interpret adequately the information that it receives from its sensors and then translate it to some movements around the Mars so that it would avoid dangerous areas, for example, and it would find the probes that are most relevant for scientists.
But the last one, isn't it a system, not an agent?
The last one, it is, yes, well, it is a system, I agree, but conceptually, it is in many cases it is useful to view organizations as agents, because like lawyers, lawyers talk about organizations, enterprises as persons. So, and this is a bit similar. So we can model different institutions like Tallinn University of Technology or some company as an agent. And this can be really helpful, at least at the stage of problem domain analysis. And later on, we might actually come up with a solution for a particular company where the software agent represents then that company in transactions with the other companies. And that was one of the research projects I did in Finland, where I worked for the Technical Research Center of Finland for 8 years. So in that research project, we investigated a solution where different companies would be represented by software agents, and then the software agents would actually trade on behalf of the companies that they represent. So it was a solution for business-to-business electronic commerce. Okay, now questions to you. So what about these examples here? Well, let's take the web crawler. So web crawler is some kind of spider that is able to, digital spider that is able to crawl around the World Wide Web in search of information, for example. So would you regard this crawler as an agent? Yes, yeah. This is this actually requirement for being social.
Yes.
Yep. Any other opinions?
Virus is probably antisocial.
Yep. Virus.
Still an agent, though, yeah?
Yes, yes. Yes, I agree, because virus actually needs to perceive its environment. It needs to interact with someone, somewhere. I think most viruses actually they supply information to someone. So in this sense, virus is one agent and there is another agent somewhere else, and they interact with each other. And it definitely is. I think it is also proactive because it needs to is it? Yes, to spread itself, yes, and also needs to reason about any new environment that it has entered, any new computer, and needs to take decisions, how to harm that environment. Yes, so virus is definitely an agent, even though antisocial, as you said. What about email handler, your email client? Can it be viewed as an agent? So whatever email system you use, let's say, not everyone uses email client, but let's suppose you have an email client and there is a server somewhere. So can your email client, like Firefox client, for example, or or some other system, can it be viewed as an agent? You would say no?
I would say no.
Yeah. Any other opinions? Just gathering opinions.
I would say yes.
Yes, and why?
Because it requires some user feedback about what is spam and what is not, and after it has learned sufficiently, it can make its own decisions. So basically, it is social with human.
Yes, yes, yep. Good, thank you. Any other views on this? So does email client comply with the definition of agent? Yes, I would say yes, actually. Partially because of what you said, because it needs to know about different viruses, for example, and needs to learn, needs to update its knowledge base, but also because you delegate something to your email client. And what you delegate is knowledge about networks, knowledge about how to retrieve your emails from the server, because there is a lot of really low level knowledge required for that. For example, I do not know how to deal with all this low level stuff, what ports to use, what IP numbers to use and so on. So I do not know about it, but my email client does know about it. So this means that in a way I have delegated all these different activities that are related to various technical details. I've delegated them to my email client, and that email client is then agent in the sense of someone representing me. But also I think it is also proactive in the sense that you explained. It's able to learn, and then it is able to act based on the knowledge it has learned. And it should be reactive, should react to new viruses that come up almost every day. So, and what about cell phone, mobile phone? So I think you already mentioned that this can be viewed as an agent conceptually. Of course, there can be other agents that are actually work on your cell phone. So in this sense, the cell phone as such can be viewed as an agent, but it can include other agents. Actually, mobile devices, this is an interesting area for social intelligent information systems, because they are personal, they are social, and they are aware of their location, at least up to the granularity of a GSM cell. So I think that's why also most of the teams here, they actually are trying to build some kind of social application or social information system. And also, in addition to that, they can perceive their immediate environment through embedded light, sound, and motion sensors. So then the next important concept is system. So what is system? So what do you think? What is a system?
Holds agents.
Sorry?
The system holds agents or something.
Yes, but in a more general sense, what is a system? Network of agents. Yeah, now we are going into multi-agent systems right away, but in a more general sense, how would you define a system, or how would you characterize a system?
The unit that can be divided into parts.
Yes. Yep. or maybe the other way around, some units that make up a whole, some interrelated units that work in a coherent way. So, and this is the definition: a set of entities or components connected together to make a complex whole or perform a complex function, like so to say, official definition. Then an important notion for our course is a socio-technical system. And a socio-technical system is a system that consists of both humans as well as technical components. And we use for both humans and technical components the abstraction of agent. So the definition is that a socio-technical system is a software-intensive system that has defined operational processes followed by human operators, and which operates within an organization. And this operating within an organization is very important here. So when agents, that make up a socio-technical system, so they make up an organization and then they operate within that organization. That comprises both humans and man-made agents like software agents or robots, or maybe just software components that we can still view as agents, like service providers that someone mentioned here in the morning, or mediators. They can also be regarded as agents. So I'm not actually sticking to the meaning of the intelligent software agent, but I'm viewing this notion of agent more broadly as an abstraction that is appropriate for developing intelligent distributed open systems. And then there is another definition for a socio-technical system. It is a system that contains both the social aspect, which may form one subsystem, and a technical aspect. Okay, and then we already, I think, covered this multi-agent system, because someone mentioned that a multi-agent system is a system consisting of several agents. And this is absolutely true. The system consisting of several interacting agents. I would add one thing: several interacting agents. Another way to put it is that a multi-agent system is rooted in the peer-to-peer paradigm, because in principle each agent forming a multi-agent system can interact with any other agent. Then these interactions are asynchronous between agents, and of course there need to be agents themselves as well. And this is a good example of a multi-agent system. It is by one of my PhD students who comes from Tanzania, and he's currently in summer holidays in Tanzania, but he found it from somewhere. And it's a very good illustration of a multi-agent system. So why? Yes.
They all in one board.
Yes, like you said, everyone is contributing something. Yes, I mean, then everyone, is doing something so that the boat would move forward. Yes, but what else?
Quantity, 14 pairs of hands.
Excuse me.
Quantity, 14 pairs of hands.
Quantity.
Yeah.
Even the people. Yes. How many people?
That's very important as well.
Yes. No, not too many. Yeah, exactly. Yeah, it's just appropriate number of people, appropriate number of agents.
The guy in the back is probably a navigator.
Yes. So this actually refers to roles. So there are specific roles required here. So what else is important here? And just forget about technical meaning, just about this.
They contribute into one goal to achieve. They move somewhere and all do something to achieve the goal.
Yes.
Coordination.
Yes. Yeah, coordination is. But contributing to one goal, excellent, actually, because this is what we are aiming at. I mean, I would like to actually teach you already today how to model the goals set for the system. You know, we need always to start, when we start designing a system, then we need to start with the purpose of the system, which is that one goal you mentioned. And then we split that purpose into several sub-goals, each representing a specific functionality of the system to be. But yes, always a system needs to have that purpose, that one goal. And here it is getting somewhere. Yes, getting somewhere. So someone mentioned coordination, and coordination is actually related to interactions. Is it? I mean, these agents here need to interact somehow to coordinate their activities. And it's not. I mean, it's not definite. It's not necessarily exchanging verbal messages. That I mean, now actually go left or go right, but it's more intuitive here, and more somehow. I mean, somehow they perceive each other, and somehow I mean somehow the system works. Anything else important for this multi-agent system? So does there need to be a leader? Is there some one person, or not necessarily?
Not necessarily.
There needs to be a master agent.
Master agent. I mean, do we need it or not?
Yes, you do.
Not always, I think. If they are, how to say, know each other very well, they can actually do just.
I think there should always be a leader.
They need.
There
It's
should
like-
be a leader. Of
Yeah.
course, everybody does what he feels.
It's like in every system, you have to have a master controller.
Yep. Yeah. So, yep. Any other opinions?
The one who is responsible for, probably yes, but the one who will constantly lead the team, I don't agree. Probably not.
Let's say bigger efficiency would be if they do have it, but if they do not have the strongest lead.
The strongest. Yes. Yep. So probably there needs to be someone who knows, I mean, where they need to go. Of course, in many cases, all of them know about it. But I think
There has to be a master navigator.
yes, master navigator. Yes. Yes. Maybe the guy here. I don't know. But there is no no rule or something like that you would use for actually driving this thing. Looks like it's all based on these sticks or things. Yep. But there needs to be someone who is aware of the purpose of the system. So someone needs to be aware. I mean, the purpose of the system is to get somewhere. So and some of them should know, but not necessarily everyone. Of course, I presume that in this case all of them know about their destination, but it's not necessarily the case. So, but still, someone needs to be aware of the purpose of the system. And when we talk about socio-technical systems that consist of both social components, I mean humans, and software components, then I think in the present world that someone is a human who knows about the purpose of the system. Any other comments about this system? So it's a good example of a multi-agent system, and also a good example of a socio-technical system, because it's not just a social system, but it also includes technology. Well, analog technology in this case, but still technology.
And it seems that it's not very stable system.
Yeah, exactly. Not very stable. And some of such systems, they can actually exhibit the so-called emergent behavior. So meaning that that some unexpected behavior can occur, that actually this that it doesn't correspond to the goal of the system, but the system is going to do something totally different, or will move in some totally different direction because of some unexpected way how these agents here collaborate. So this is a well-known phenomenon actually in science, and especially in multi-agent systems, emergent behavior that no one expects, but that somehow emerges. there are a few examples of multi-agent systems other than that boat with rowers, like intelligent home that already got mentioned here. There can be a multi-agent system for guarding, for intruder detection alone, not to mention other areas of intelligent home. And as I remember, one of the teams here actually is also dealing with smart home. Electronic commerce, I already mentioned that agents representing companies and trading between each other. Social networking services such as Facebook, they can also be viewed as multi-agent systems conceptually, because there are agents, these agents interact with each other, and they somehow affect each other through this, through the Facebook, for example. So any other ideas about multi-agent systems in general?
Actually, some supermarkets can be like people were
Yes.
checking the products.
Yes.
saying
Yes.
they know.
Yep. Yeah, definitely. By the way, one of the most successful areas where multi-agent systems, I mean systems consisting of software agents, have been applied is simulation. And for example, a supermarket can be simulated by means of software agents. And this is, in many cases, actually, it is actually very good to have to simulate it, because, for example, for emergency situations, I mean, how else would you know? I mean, how people how they are most likely to behave in emergency situations. So you can try out things that you necessarily do not try out in real life. Any other ideas about multi-agent systems in a general sense? So please, so you don't need to be shy, because at least I hope I'm not getting too technical here, because now I'm talking about still about both human systems, technical systems, and combined systems. So it doesn't have to be technical. I know that the background of quite a few of you is not so technical. In general, what do you think about multi-agent systems? Are there any good examples? The university, perhaps, yeah, as a multi-agent system. It's a complicated one which has a purpose, I think, and different sub-goals for different sub-areas, like teaching students, doing research, collaborating with industry, helping industry. Okay, now I'm about to wrap up this session soon, because the lunch is approaching. This you know by heart, don't you? The business model canvas. So you all have your business models for these different applications that you have done in your teams, right? And you have filled out this canvas. So you have like identified key partners for your idea and key activities, and definitely value proposition. So this you have done. And now you understand also, because of this canvas, you understand why a framework is important. So why is it important to have some kind of mental framework for modeling? Because here what you have done business modeling based on a certain framework. And now I would like to do, in this course, I would like to introduce another framework, which is not about business model, but it's about a product to be designed. So it's a framework for a product design. And it is called the viewpoint framework. And the purpose of the viewpoint framework is to enable different perspectives of view on your product. Because when you start designing your product, you need to model your product represented from different perspectives. So, and these perspectives are interaction, because most of the products that you have envisioned, they are social by nature, as I've understood. So you need to address the interactions in one way or another. Then you need to address information, because these products, according to my understanding, in all of them, you need extensive information processing in one form or another. And you need to address behavior. So this is about algorithms. I mean, how the components of your system, how they would behave. So what is the actual way of reasoning in your system? So these are the three vertical aspects you need to address. But in addition to this, you need to do this at different abstraction layers, horizontally. Well, first of all, you have analysis, where you analyze your problem domain at hand, and you conceptualize your product idea. You represent it by different analysis models from different vertical perspectives in interaction, information, and behavior. And as a result, you obtain even better idea of the product to be than you have now. Because now you have been thinking about the business plan, but then you will be thinking about the product to be designed more specifically, more concretely. Then you need to do the design. So after you have done the analysis, you have developed a sound model for your product. Then you need to go to actually designing your product. And again, different models representing different vertical perspectives of design are helpful here. And we're going to go through these models, even though I'm afraid that here we do not have enough time actually to do it in detail, but we will see it later this week. And finally, just like in case of a business model, you need to do prototyping, because there is a term, business model prototyping. You somehow prototype your business model, you somehow act it out. So the same should be done with your product. You should somehow act out your product, either manually between people, or preferably using some software solution. This means that you work out a rapid prototype and then show that rapid prototype to your stakeholders. And ask, is this what you meant? For example, you show your rapid prototype to a venture capitalist and ask, would this do? This is much better than just talking about ideas to venture capitalists, but it's much better to come up with actually something working, which is not a product yet, but it actually represents in a quite adequate way what the product will look like. Here we distinguish between interaction prototyping, information prototyping, and behavior prototyping. But because it's of the length of this course, I'm afraid we cannot do it in practice. I will give an overview on Friday about this prototyping, and I will also bring some examples. I will actually demonstrate some examples, some video shots. But we don't have time to do it in practice, unfortunately. So we would need another week to do it in practice. So the viewpoint framework constitutes a central part of our course, because it structures the way we analyze, design, and prototype our product. So, and I have yet to cover the meaning of a model, because you can see that this viewpoint framework this consists of different models that represent your product from different perspectives and different abstraction layers, like role models, domain model, goal models for analysis. So before going into specific models, we need to cover the notion of model. But I think now it's time for lunch, and then we will take up from there. So many thanks for your attention. Thank you.